Hi Year 9, I'm going to go through your simultaneous equations forms assessment. There will be timestamps in the description. Right, in question 1, we're actually given the graph. We're given the graph of y equals x minus 4, so it has a gradient of 1, so 1 along, 1 up, 1 along, 1 up, and it goes through minus 4, so this is the green line here, and then we've got the graph, the line drawn y equals minus x. And so where these coordinates, where these lines actually cross, which is here, they both have to be satisfied at the same time, right? So here is a coordinate on the green line, so it satisfies y equals x minus 4. So whatever x and y are there, it's on the green line, but it's also at the same time on the yellow line. So whatever the x and y value at that point makes both of these true at the same time. So that's why they're called simultaneous equations. So of course this coordinate here is 2 minus 2. So you could have written 2 minus 2. You could have also written x is 2, y is minus 2. Either of these would have been absolutely fine answers. I did have to manually mark some people who didn't put the brackets on the coordinates. Now just remember, coordinates have brackets, so you do need to write the brackets. Right, and then this question's basically the same idea. You've got the two graphs drawn, and where they cross is the solution to the simultaneous equation, right? What you've really got to have in your mind is at that coordinate there that I've circled, this one, not only does y equal x minus 1, but also 2x add 3y equals 12. So the x number and the y number at this coordinate works for this, and it also works for this. So that's got to be the solution to this pair of simultaneous equations. So that's 3, 2. Right, number 3. So it does start to get just that little bit more difficult, because now there's 3 lines drawn when one of them is kind of there to try to trick you. It says, using the graph below, find the solution to the simultaneous equations, and you've got 2 equations here. Now y equals minus a half x. This is a negative gradient, so it's going downhill. So there's only one of these lines that's going downhill, and that's this one here. So it's going to either be this coordinate here or this coordinate here that we're going to put as our answer. And it just depends on whether or not we're after the purple line or the yellow line. Y equals 2x minus 1 has a gradient of 2, which the purple line has and the yellow line has, but it goes through minus 1 on the y-axis. So we don't actually want this one, we want this one, which is a coordinate 0, minus 1. Okay, so the first simultaneous equations here, where it doesn't give you a graph, it's wanting you presumably to solve it algebraically. So in this situation, we've got the y numbers are the same, and the signs are the same. So basically there's a little thing that you try to remember: same signs subtract. So if they were both minuses, you would subtract. You've got to make sure that the letters are the same. So we're on about the y's here. We've got 3y and we've got 3y, and they're both plus, so we're going to subtract the bottom one from the top one. So 4x take away 2x gives me 2x. 3y take away 3y just leaves me with nothing, and then 5 take away 1 is 4. So this tells me that x is 2. So this is almost done. I could start by writing 2, and then I need to work out what y is. Now the way you figure out what y is you actually substitute back in your x number to either of your equations. So let's take a look at 4x add 3y equals 5. So instead of x, I have 2. Right, we've just figured out that x is 2. So now we've got 8 add 3y is 5, and if you solve this, you get y is minus 1. So you'd have 2 minus 1. You could obviously, again, you could write x equals 2, y equals minus 1. You know, there's lots of ways you could write your answer. Right, number 5. So 2x minus y is 7, 3x add y is 18. And now we've got the same number in front. If you ignore the sign, it's 1y and it's 1y. So that's good, but we've got a minus y and we've got a plus y. So in this situation, we've got different signs, so we add. So if I add the top to the bottom, 2x add 3x is 5x, minus y plus a y is nothing, and that's the idea, right? We eliminate one of the variables. 7 add 18 is 25, and so this gives us x is 5. And then if I substitute that into this one, I'll have 10 minus y equals 7, which would make y be 3. So I've got 5, 3. Now you can always double check, right? Before you press the submit button, you could double check your answer. For example, does 5, 3 work for the second one, right? So you could test it out on this. Right, so if you put x is 5, you do 3 times 5 is 15. Then when you add 3, do you get 18? Yes, great. So 5, 3 is the right answer. Okay, number 6. So this is the first one where the numbers in front of the x's and the numbers in front of the y's are different. So this is a step up in terms of the difficulty, okay? So one thing you could do is you could label them, so equation 1 and equation 2. And for this one, I will answer it twice. I'm going to answer this question twice. The first time I'll eliminate y, and the second time I'll eliminate x, and we'll see how we get the same answer either way. So if I want to eliminate y, I need to make the numbers in front of the y's be the same. So what I could do is I could do 4 times equation 1. So that would be 20x plus 12y. 27 doubled is 54, doubled is 108. And I could do 3 times equation 2. Remember, I'm going to times everything by 3. So it's going to be 6x add 12y is 24. And this was the idea, right? We chose numbers such that we'd end up with the same thing in front of the y's, right? Because I want to eliminate y. So when I subtract, I'm left with 14x equals, so this is 108, take away 4 is 104, take away 20 is 84. Divide by 2 this equation, so 7x is 42, and divide by 7 I get x is 6. Okay, so eliminating y gives me that x is 6. And then I don't know, I might as well substitute it into the easier of the two. So 2x add 4y is 8. 2 times 6 is 12, so 12 add 4y is 8. So this is 4y is minus 4, so y is minus 1. So the answer that I get is 6 minus 1. So I should get 6 minus 1. Now, let's see if this time, if I eliminate x, I get the same answer. I should do. So if I want to eliminate x, I will do 2 times equation 1, which will give me 10x add 6y is 54. And I should do 5 times equation 2. This gives me 10x add 20y is 40. When I subtract, this gives me minus 14y is minus 14, which means that y must be minus 1. And then I would just substitute that back in. So 2x add 4y is 8. So 2x minus 4 is 8. 2x will equal 12. X will equal 6. And then if I was doing it this way round, what I'd have to be careful. I shouldn't write minus 1, 6. X comes before y, so I will put 6 minus 1. And I get the same answer as I did before. Okay, so really the only place you go wrong is if you make a silly mistake, or if you make a mistake with your arithmetic, you do something wrong with the minus numbers or your substitution or something like that. Of course this can happen, and really you just need to be careful. Right, number 7. So number 7 is actually not simultaneous equations. It's kind of just there as a precursor to question 8, and also a bit of revision, right? Can you remember how to do this? Well, remember, y equals mx plus c. In this, when written like this, with y being the subject all by itself, you've got the gradient in front of the x, and you've got the y-intercept here. This is because if x is 0, then this mx is actually just 0, so you've got y would be c. So that's your y-intercept. And then this being the gradient is just because if you make x be 1 more, y will be m more. And that's exactly what it would mean to have a gradient of m. So anyway, there's your tiny little reminder. Let's have a look at the plus c. Well, the plus c is 2, so it's going to have a plus 2. And then the gradient, it goes 1 along and 3 up. And the gradient is the up over the along, which will be 3 over 1, which is 3. So it's y equals 3x plus 2. Right, number 8. So a few people struggled on number 8, but we also had some people get the right answer, which was really good. Clearly, question 8 is a little bit complicated, so let me try to explain as clearly as I possibly can how you answer it. So we've got two equations both with a y and an x in them, right? And if I plot either of them separately, I'm going to get a straight line. And if I plot them both at the same time, then wherever they cross will be the solution to those simultaneous equations. So the question is actually, which of these lines are these two equations? And the easiest way of figuring that out is to make y the subject, because then you have y equals mx plus c. So for the first one, I'm just going to take away 2x. So this is y equals minus 2x, add 7. So one of these lines is y is minus 2x, add 7. Okay, so it's got to go through 7. So it's either the red or the blue. It's got a negative gradient, which means it's going downhill, which means it must be the blue line. So this is y is minus 2x, add 7. And of course, what we could think of it kind of back again as y add 2x equals 7. So that's that one. So it has to have a blue line in it. So it can't be this one, it can't be this one, it can't be this one. 2y add x equals 0. 2y add x equals 0. Well, let's make y the subject. So 2y will be minus x, and then y will be minus a half x. Okay, so it's got a negative gradient, and it's different to the blue line. It also goes through 0 on the y-axis, right? It goes through 0, 0. Well, that's the purple line. That's the purple line. That's the purple line there. And where they cross, which is here, will be the solution to this pair of simultaneous equations. The fact that the green line goes through there as well is irrelevant to the question. Okay, if we want to solve these simultaneous equations, we work out where this blue line and this purple line cross. So it's the blue and the purple. I'll just take a moment just to say, look, if you want any more detail on any of these questions or you didn't quite follow an explanation, please send me an email. I'd like to think that I actually give good answers in emails. You know, I've had several people email me across all of my classes, and I always try to answer the emails as well as I can. And I think most people have found it useful. So if you are stuck on anything or struggling on anything, please do just get in touch. Right, number 9. So number 9 is just it's a simultaneous equation question. It's a tricky one because we've got minuses, we've got different numbers floating everywhere. X is written before Y in this one, and then Y is written before X in this one. So there's a bit of work to do. There's a bit of tidying up. So this time I'm just going to do it one way. And the very first thing I will do is write the equations out. So number 1 is 3x minus 4y equals 5. And then number 2, I'm going to write minus 2x plus 3y is minus 2. So I've changed the order here. I've written the minus 2x at the front plus the 3y. Plus the 3y. That's so that the x's and the y's are in the same order, and you can have a think about what to times the first one and the second one by. So what I'm going to do is eliminate the y's. I'm going to times the first one by 2. So equation 1 times 2 gives me 6x minus 8y is 10. And I'm going to times the second one by 3. So equation 2 times 3 is minus 6x plus 9y is minus 6. And the reason I've done this is now I've got a 6x and a minus 6x, I can add these two things together. So when I add them up, minus 8y, add 9y, I was down at minus 8, but now I go all the way back up to 1y, and 10 take away 6 is 4. So this actually straight away gives me that y must be 4. Right, and then let's just substitute it in. So 3x minus 16 is 5. 3x is 21. So I've substituted it into the first one, right? 4 times 4 is 16. So there's where the 16 comes from. 3x is 21, so x is 7. So we should have 7, 4 as our answer. Just going to double check. Great, super. Okay, right, number 10. So number 10, number 11, and number 12 start to become a little bit more problem solving. Number 10 is a one you could actually just do by trial and error, but let me show you how to set up and solve some simultaneous equations that will actually get you the answer. So we're going to have A and B are our positive integers. Now, since their difference is not 0, it means that they're different, which means one is bigger than the other. So we're going to say that A is going to be bigger than B. Okay, we can say which way around we want to write them. Okay, so A is going to be the bigger one. So we know that when we add them both up, we get 90. And we know that if we take their difference, which will be A take away B, because we'd start with the bigger one, we get 4. So this is just a pair of simultaneous equations. So when I add them together, I'll get 2A equals 94, which means that A is 47. And if A is 47, I would need to take away 43 to get 4. So B will be 43. And then it turns out that their product, 47 times 43, because remember it's asking what is their product, is 2021. Right, number 11. So we've got Alex and Ben. They go to a cafe with some friends. Alex buys 4 cups of coffee and 3 cups of tea, and he pays a total of $6.95. Ben buys 5 cups of coffee and 2 cups of tea, pays a total of £7.20. Work out the difference in price between a cup of coffee and a cup of tea. Okay, so straight away, it's simultaneous equations. We might think to ourselves it's simultaneous equations because it's on an assessment about simultaneous equations, but this is an actual GCSE question, and of course it would just be randomly in the middle of other questions. So you'd need to read this and think to yourself, yes, I need to use simultaneous equations. So the simultaneous equations are simply that we have 4C plus 3T, so 4 coffees and 3 teas. So C is going to be the price of a cup of coffee, and T will be the price of a cup of tea. When we do 4C plus 3T, we get 6.95. And if we do 5C plus 2T, we get 7.2. So we're going to just deal with numbers right now and convert back to money at the end. So let's times the first one by 2. And the second one by 3, right? That will make the numbers in front of the t's be the same. We could also have times the first one by 5 and the second one by 4, and then that would make the numbers in front of the c's be the same. We'll end up with the same answer, so we might as well pick the smaller numbers to be easier. So equation 1 times 2 gives me 8c plus 6t is... and I've got my calculator here. 6.95 doubled is 13.9. And equation 2 multiplied by 3 is 15c plus 6t is 7.2 times 3, which is 21.6. And what I really want to do is do the bottom one here, take away the top one. So that's what I'm actually going to do. I'm going to write the answer to that underneath. So 15 take away 8 is 7. So 7c will be whatever 21.6 take away 13.9 is, which is 7.7, which means that a cup of coffee is 1.1 or £1.10, right? That's £1.10. So to be, and this you could theoretically do this without a calculator as well. It's just obviously easier with a calculator. Right, and then how do we figure out what is the price of a cup of tea? Well, let's just substitute it back into this first one here. So we'll have 4.4 add 3t is 6.95, which means 3t is 6.95 minus 4.4, which is 2.55. Which means that 1t is 0.85 or 85 pence. And it's asking for the difference in the price. So I have to do £1.10 take away 85 pence, and that is 25 pence. So I actually allowed a few different ways you could write the answer. So I was very lenient. So you could have written either 25 or 0.25. And you could have written it with or without units. So we were looking for the number 0.25 or 25, depending on if you're in pounds or pence. Right, number 12. So you'd have to remember what a Fibonacci-like sequence is. Clearly, if you'd forgotten, then this question kind of comes out of the blue, but you have to, you do have to start to be prepared for that sort of thing, okay? You can't just forget your previous learning, okay? So just a reminder on what a Fibonacci-like sequence is. So a Fibonacci-like sequence starts with 2 numbers, so maybe it starts 3 and then 4. And then what you do is you add up the previous 2 to get the next one. So 3 add 4 is 7, 4 add 7 is 11, 7 add 11 is 18, 18 add 11 is 29, and then it keeps going like that. So this would be a Fibonacci-like sequence. The actual Fibonacci sequence is a Fibonacci-like sequence that starts 1, 1. Or they say it could also start 0, 1, and that we're not sure which one is the actual classical true one. But in any regard, we do end up with the same numbers. So 0 add 1 is 1, 1 add 1 is 2, 1 add 2 is 3, 2 add 3 is 5, And it keeps going. So this is the Fibonacci sequence, right? In any case, what do we have? We have a first number, and then a 7, and then a fourth number, a fifth number, and then a sixth number of 30. And then it keeps going. And the question is what's this number here? Right, so let me show you how we can work this out using algebra. It was the last question for a reason, okay? It was a challenging question. Supposed to be, you know, you're a top set. A lot of you are aiming for 8s and higher, so you need to have a question like this. So your general form of a Fibonacci-like sequence will have the first number A and the second number B. Okay? A and B can actually be anything we want, right? If I make A be 10 and B be 7, then the next number would be 17, then the one after that would be 24, and then it would keep going, right? So you can set A and B to be anything you like, but once you've done this, you actually set in stone the rest of the sequence. So the next term will be A plus B. The term after will be, so I'd add up these, and this would be A plus 2B. Then I'd add up these and I'd get 2A plus 3B. Then I'd add up these and get 3A plus 5B. And then, okay, I'd add up these and get 5A plus 8B. And then, okay, it keeps going. And what we're told is that this one here is 7. And this one here is 30. Now, if you'd like to pause the video and actually now have a go at it yourself, now that you've seen this beginning part of how to answer this question, pause the video now. I'll give you a couple of seconds and then I'll answer it and you can see if you get the answer. Okay, right. So for those of you that managed to do it, well done. You're about to find out if you are correct. And for those of you that just want to continue, here's the full solution. So we have A plus B will be 7, and 3A plus 5B will be 30. Now, one thing I can do to this equation here is just times it by 3. If I do that, I'll have 3A plus 3B is 21. Now, if I take that away from this, I'll have 2B equals 9, which means that B is 4.5. And what do I need to add to 4.5 to make 7? Well, A would need to be 2.5. So 2.5. You could have also written 5 over 2. Okay, I did allow equivalent representations of the answer. There you go. So, any further questions, please get in touch. Okay, it's at the end of the day. I know you're only in year 9, but you know you have to take some ownership of your own GCSE. Okay, you have to take some ownership of it, and you want to be doing as well as you possibly can. Which means if you don't fully understand something, you need to be pestering me for help. Okay, I'm actively encouraging it. I really am. Anyway, I hope you all have a good half term, and I will see you. Well, I'll see you when? Monday, the 22nd. Right, bye guys.